Okay, 10.3 is two-way tables and probability. Okay, so first I want to just recap what happened in the last section really quickly, because independent and dependent events are going to get confused with compound events sometimes. So this is all stuff from 10.2. Okay, but an independent or dependent event is one event followed by another. So we're having one thing happening, then another. We're finding the probability that those two or more things are going to happen. Okay, we use the word "and" when we're talking about dependent and independent and dependent events. Okay, so the probability of flipping a coin and having come up heads and heads on the second throw or something like that. Okay. And here are the formulas. When they're independent events where the outcomes don't affect each other, you just multiply them together. Dependent events you multiply as well, but on the second event you got to assume that the first event has already happened. Okay, so compound events, which is what we're going to be working on in this section, is where we've got one event where two or more outcomes are described. Okay, and this is going to use the word "or." Okay, and there's two types. We can have mutually exclusive events and inclusive events, and we're going to start with the mutually exclusive ones. So compound events that mutually exclusive means they're compound events that cannot happen at the same time. Okay, so let's look at. I'll show you with an example. So if we got one card that is randomly drawn from a deck, find the probability that the card is a jack or a queen. We've got this word "or." Well, you can't pull out a card that is a jack and a queen. Those things can't happen at the same time, which means they're mutually exclusive. You could have one or the other. You could have neither, but they're not both going to happen with the same card. Okay? So here's the formula. We're just going to have more favorable outcomes. When we're looking at favorable outcomes are going to be jacks or queens, so you just add the probabilities together, okay? Because when we're adding fractions, we need a common denominator, and that denominator is going to stay the same, okay? So here we're going to take the probability of pulling a jack, and since we're just drawing one card here, we're going to add in the probability of pulling a queen, okay? So the jacks, those are 4 out of the 52 cards here, right? And there's also 4 queens. So then I just add those together. The denominator stays the same. We already have a common denominator. That's nice. 4 plus 4 is 8. So there's 8 favorable cards in there, right? So it's 8 out of the 52, which we can reduce to 2/13. And that would be about 15.4%. Okay, 4 goes into 52. That's good to just remember. So does 13. 4 times 13, because there's 4 kings, 4 queens, and so forth, and there's 13 different types of cards. Okay, so let's take a look at another here. We've got now a diamond or a heart, pulling a diamond or a heart. All right, so I'm going to just find the probability of pulling a diamond plus the probability of pulling a heart. So there's no card that's a diamond and a heart. They're different suits, right? So it's a little hard to see, but they've got the diamonds are all here, and the hearts are here. So there's no cards that are in both of those categories. They're mutually exclusive. So there are 13 diamonds in the deck out of 52 cards, and there's also 13 hearts. Okay, and these are going to both reduce to 1/4 because 13 goes into 52 4 times. So I'll reduce them first. You could add them together right now. It doesn't really matter. But then when we add the fractions together, we'll get 2/4, which is going to be 1/2 or 50%. You know, if you add these together, you get 26 over 52, which is also 1/2. Okay. All right. So let's look at what is going to happen when you have inclusive events, and this is a little trickier because we can have the same thing. We can have both events can happen at the same time, so it's a little trickier. Okay, so let's just kind of talk through this example a little bit. We're going to pull out a queen or a heart. So we're going to draw one card, and we want to check if it's going to be a queen or a heart. So we're going to kind of start in the same way, because there's all the queens and all the hearts are going to be favorable outcomes. Okay, so that's the start of our formula. But let's think about this. Is there a queen of hearts? Right, here are my queens, and then here are my hearts, and there's one card that is a queen and a heart. So that's why these are inclusive. They can both happen at the same time, both of those events. So if I just added up these 13 cards and those 4 cards as my favorables, I'd be double counting the queen of hearts because it's in both of those categories. So the way I like to describe this, I want to subtract out the probability that both things are going to happen at once. So that's how I write the formula. Okay, so I'm going to do the same thing here. So let's think through this. The queens, there are 4 of the 52 cards, and the hearts, there are 13 of them, right? But we've double counted the queen of hearts, so we're going to account for that by subtracting out the one card that is in both of those categories, and that way we're not double counting the queen of hearts. Okay, so then I add it all up, and I'll actually reduce these first. No, I won't. Why would I reduce them? If I reduce them, I wouldn't have the same denominator. Let's keep the same denominator here. So I've got 4 plus 13 is 17, minus 1 would be 16 out of 52. And now I'll reduce it. That's going to reduce to 4/13. Okay. All right, so let's try another. Let's look at the probability of pulling. Oh, this has the same thing here. I'll switch this on the note-taking guide. I must have copied and pasted and forgot to change that. This should say the probability of red or a king. So let's try a new one here. Okay, so let's look at the red cards. Well, the red cards are the they're the hearts and the diamonds, and you know, this is not color printing, but these are my red cards. Yeah, this is probably hard to read, but those are the red ones. Okay, and then the kings are those. So just looking at what I've highlighted there, I can see, oh, these are inclusive events. Both of those things can happen at the same time. So I'm going to find the probability of pulling a red card plus the probability of pulling a king. And then I'm going to subtract out the probability that both of those things are happening at the same time. Okay, so the red cards are half the deck. It's going to be 26 out of the 52 cards. I'm just going to leave it as 26 out of 52 to make sure I'm going to have a common denominator, because I'm going to do some addition here, right? And the kings are 4 out of the 52 cards. And then I'm thinking, how many red kings are there? Well, there's a king of hearts and a king of diamonds, so there are 2 cards that are in both categories there. So there's 2 cards that would fulfill both of the red. I even said red king there. I just forgot to change it there. Okay, so then I'll add everything up. So 26 plus 4 would be 30. Subtract 2 from that, and I get 28 out of 52, which is going to be 7/13 reduced if you divide by 4 on top and bottom. Okay. All right, and then let's try a number cube one. Find the probability. We're going to just a number cube is rolled, one number cube. So a dice, right? A die. Find the probability that it comes up 3 or odd. Well, 3 is an odd number, so if I roll a 3, it's in both of these categories, right? So the 3 is a favorable outcome. Any of the odds are favorable outcomes, but I don't want to double count the 3 because it's in both of those categories. Okay, and you could just, there's not that many possibilities here for outcomes, so you could kind of just think through all the outcomes. But let's do this with the formula. So there's one number that is a 3 out of 6. The odds, there's 3 of them, 1, 3, and 5, right? 3 out of the 6 things you can roll are odd. And then I'm thinking, how many things are 3 or odd? Well, one thing, right? So we don't want to double count the 3 because it's already an odd number. So then that's going to leave me with 3 out of 6. So the favorable outcomes here are 1, 3, and 5, which is half of the things that can happen. Okay, that's the end of the section, and I'll see you next time.